Yeah, I'm pleased to be invited to here to share some experience in Taiwan. First, I would like to introduce myself, and indeed, I took the Office of Water Resources in Taiwan around 7 years. You know, such kind of work is tough, but I'm still alive. and, and at first, I will introduce my agency. My agency in charge of the water-related things in Taiwan, especially to deal with the problem too much water and the problem of too less water. This is some common things in your country, maybe around the world. Right now, we can see some of problem getting more worse and worse, especially in some of country like Taiwan. Taiwan is a small country, but Taiwan with diverse environment. We have a huge high mountain. There are around more than 100 mountain. The elevation of this mountain is higher than 3,000 meter. So you can recognize the steep of the river is the slope of the river is quite steep. So it's hard for our country to keep the water in the reservoirs. And we rely on the typhoon to bring the water to fill the reservoir. But unfortunately, for the past 4 years, all of the typhoon in southern Pacific Ocean, they are all got the ticket to Japan. So there are no typhoon in bad Taiwan. So we have a severe problem of drought. Later on, I will talk about such kind of problem. And I think all of you can recognize the charts. The charts is come from World Economic Forum. The major risk for the individuals around the world, they are facing the problem of the coming from the natures, especially on the problem of the flood and the drought. But indeed, this map shows the red part of this map shows there are many countries that are facing the problem the same as Taiwan right now. The problem in China, the problem in South America, the problem in Europe. I flew to New Zealand this June. The office of New Zealand government, as they told me, for the past 5 years, the New Zealand government, New Zealand people also facing a consecutive of 4 years of drought. So this kind of problem is getting worse and worse. Most of people can recognize the climate change go first. I'm using the shock. That means the speed of the climate change that impact of the individual around the world is so quickly. But the damage to the individual is also like the shock as well. According to the research in Taiwan, they found out by the end of these centuries, the temperature was getting higher and higher, and the intensity of rainfalls even up to 41% compared to the intensity of rainfall right now. There could be more worse. That means we cannot get enough water during a short times. But when the precipitation is getting higher, within a short times, that could be a cause of severe damage for our living environment. Especially there are around 2/3 of population in Taiwan, they are living in a mega city like the Taipei city. We have six municipal big city, Taipei, Kaohsiung, Taichung, Tainan. They are also facing the problem. And when I got 80s, right nowadays, I'm 55 years ago. We are 55 years old. That means at 30 years later, when I was 80s, the population in Taiwan is less than 20 million people in Taiwan, but most of people, they are living in the city. So that make the work of official in water resources we should find a new way to solve the new event situations. Later on, I will focus on three major topics on that. The topic is related to the SDGs. First of all is about the recycled waters. In the past, we use every source once at a time. But nowadays, we think every source matters. So our government set a master plan to build around 12 reclaimed recycling plants to provide the water resources for industrial use. You know, the TSMC, they provide the high technology of chips to the industrial around the world. But such kind of company, they consume a huge quantity of water. But we cannot provide the natural water, the raw water, to such kind of company. So we ask the company like the TSMC, if they want to invest more, they should use more reclaimed water in the future, even for the desalination water, seawater. And the second part, I will talk about how our agency to improve the environment, to increase the quality, because the people like to reach the water, but the water in the river sometimes maybe 30 years ago is quite dirty. So it prevent the people in Taiwan to reach the rivers. So recently we pay a lot of efforts on that. Later on, I will talk about some of innovative water opportunity in the futures. And there are 5 major tasks for our agency to tackle the SDG goals of 2, 6, and 7. I will talk about, there are around 95 reservoirs in Taiwan, but most of reservoir, the capacity of the reservoir is quite small. So that means we cannot accumulate the water in the reservoirs. And in the past, each reservoir cannot connect each other. So recently we set a goal to connect all the reservoir in the western part of Taiwan. Why we use such kind of vast plan? Because most of people living in the western part of Taiwan, on the eastern part of Taiwan, there are a rural area. There are not so many companies invest there, so the water consumed in eastern part of Taiwan is lesser than western parts. So we focus on the works on the western part of Taiwan. So all of the things is going through right now. In the next 5 years, we will connect each reservoir in the western part of Taiwan. We also concerned about how to reduce the problem of land subsidence. In the past, the farmer used the water, they use the well to pumping up the groundwater. But because the geological condition in Taiwan is quite complicated, so if we use a lot of water, of groundwater, that will cause the problem of land subsidence. And we work with the private. Okay. We work with a private company at TSMC, provide the technology for this automatic gate and the well. They also use the solar to provide the power for these systems. So we use this system, I can say, to provide the water for irrigations. And this system will also save the water for irrigations. According to our study, when we apply such kind of system in our farm, they can save around 6% of water for their consumption. And I will emphasize another words. We work in our reservoirs. We put the solar panels on the top of our reservoir. So we can get the power to provide the grid system for the Taiwanese people. But we also recognize the use of the power and the use of water resources should be keep on the balance on that, because most of energy of Taiwan is imported from the foreign countries. So we do need the green energy like a solar panel. And this one I will emphasize how we meet the goals of 11 and the 30s. I will show some case in here. In the past, we use a lot of lands to construct a huge detention pond. When we build such kind of facility, they use a lot of land. So we got the lands from the farmer. So farmer cannot the lands to crop. But recently, we find another ways. So we called the on-site water detentions. We do not buy the lands from the farmers. We just ask they raise the breed of their farms, so they can accumulated water during the flooding times. So if we can observe more water, there could be prevent the water come into the river so fast. So we can reduce the impact of the flooding to the people. This is another example that is under control by our agency. In the past, this map shows the rivers. Along the river, we have a huge dike. Such kind of huge dike can prevent the flooding problem, but such kind of infrastructure prevent the people to reach the water. So we cannot remove the dike along the river, but we can make our environment more convenient for the people to reach the river. So this year we initiate this plan. We hope every river in Taiwan can have such kind of environment to provide the opportunity for the people to reach the river. And finally, I will talk about some of the engagement for the private sector. We know when we initiate a huge plans, such as dam construction, we should do the environmental impact operations. But such kind of operation that took time to negotiate with the NGO, NPO, and the public. Some of the public always against the engineers to do the things to build the huge dams. That's 2 times. So we build a platform to provide the opportunity for the official of our agency to communicate with the public. We use such kind of platform for each infrastructure plans. So we gather every stakeholder to join our platform to raise their worries, to raise their questions, and maybe we can show the evidence to the public how we do things to reduce the impact of the environment. So I think that will be a chance to provide the officer to communicate to the public. Some officers in our reservoir, in our agency, asked me, DG, that 2 times, we waste times, we just going on. But I told my colleague, if we don't spend the times to communicate with the public, we will spend more times during the construction times. So for the long term, they will be short times, save times. And we also cooperate with the private sector. This shows us we work with some one of the company, the Delta company, and the TSMC company. It's a high technology company. They provide opportunity for the people living around the reservoir to bring the student to their factory to show how they conserve the water, to to make the student realize maybe we can work with them. Maybe some days the student can work in such kind of company. So we give the student dreams, but we also ask the company can do more things that is friendly to the environment, especially for the water resources for such kind of company that consume the water. This is another case of that. One of the mega company they call Micron in United States, they donate the funds, the grants to our agency to assist our agency to remove the sediment from our reservoir. You know, as I mentioned before, the slope of river in Taiwan is steep. So during the rain season, we got the water from the upstream basin, but we also got a lot of sediment coming to our reservoir. So such kind of problem bother our government. So recently, we put a lot of money to dig up the sediment from the reservoir. So the micro provide the grants to our government. So that could be another case that the government can work with the private sectors. And finally, I think everybody knows the impact of climate change. And now it's time to take action. It's not the time to waste. If we can do the action as soon as possible, maybe the shark will come out to bite the individual. So I think my time's up, and because I should leave earlier, maybe any question for my talk can, okay. So any question? Okay.
So, so let me ask you use the AR6, what kind of the RCM or GCM, you know that?
I know. Yeah. First, we maybe the Professor Tung knows more about that. Maybe.
We do have an agency to help to do the spatial statistical downscaling based on the ECM models, but some of the models is the GCM models. And we do have a regional model. Yeah, we do have a regional climate models, and but most of the scenario based on statistical downscaling, not from the regional models.
Based on the AR6 scenario,
yes.
At the end of this century, what daily rate precipitation will be increased 41.6%.
Yeah.
So, and then what am I going to do?
I've
been working on the climate change, AR5, AR6, for last more than 10 years. The problem is the rainfall, maybe rainfall intensity and the rainfall amount really increase like 30 to 40%. And then what do you want to do?
We emphasize to bring the concept to the public to live with water, because we cannot always put the money to raise the standard of the flooding preventions. Nowadays, the dreams in Taipei City, we can prevent the rainfall intensity around 78 millimeter per hour. But indeed, we saw many cases, many events, the intensity is higher than our pretension standard. So I think we cannot dig more, we cannot dig the ditch more deeper and deeper. We cannot widen our river. So the best way is communicate to. No. Yeah. First of all, I think the warning system is quite crucial for the public. So we applied the AIoT to predict the farting phone drones in their daily life. We also connect each data to our cell phone. So right now, when I stand in this classroom, I can get every data around Taiwan. So that could provide enough time for the people to adapt the environment when we facing the situation or high intensity of rainfall. Okay.
Slide number
18?
number 81.
Here? Recycle water.
Yes. I didn't get it. Using a drop of water 3.5 times.
Yeah. Most of high technology company in Taiwan, they recycle water more than 3 times. 3 times. And this year, our agency also set a regulation to ask the company when, like TSMC and Delta, such kind of the high technology companies, they consume a huge quantity of water. So we ask them to raise their recovery rate. If they cannot recover the water, they should pay more money to the government. So our agency got the money to put in the fund to build a more reclaimed water plant to assist the company to put more facility to raise their recovery. Okay.
Thank you, Dr. Lin. I just want to be sure we didn't have any questions from our online participants.
Just one thing, just clarify, what is the literal meaning of drop of water 3.5 times? Do you mean that you have a standard that if so much water is consumed, this much must be recovered, and now they are doing it 3.5 times more? Because that doesn't mean that if the water is 1,000 liters, they will produce 3,500 liters.
So half times. First of all, when we reviewed the EIA report of each company, according each kind of company, they have some property of their water consuming. For the semiconductor in Taiwan, we ask than to recover water more than 70% on that. So nowadays, we got the information from the TSMC. They want to invest a more high-end factory in Taoyuan City. So we asked the TSMC, they cannot use the natural water. They should use 100% of reclaimed water.
Thank you, Dr. Lin. I don't think we have any questions online, so, but if there is anyone later who wants a question, we'll certainly be happy to answer those as well. But it's very interesting to hear what's happening in Taiwan. I know you're in a rush to get on to your rest of your day, but thank you so much to, talking about the Sustainable Development Goals is one of our areas that TC-26, this technical committee, is looking at, and it's great to see that as part of your presentation as well. So thank you very much.
Thank you.
Great. So our next speaker is one of our TC-26 members, Dr. Lee from the Korean Society of Civil Engineers. I'll let you introduce yourself once you get your presentation up. And I think we have enough time that we can take questions after each presentation, and then we can do a general discussion after that. And I know a lot of you here in the audience have water experience, so I'd love to hear your comments and join in the discussion. So thanks so much. So just be a moment.
It's okay. I think it's.
Yeah, so we just want one.
Yeah, sure. Okay, good afternoon, ladies and gentlemen. I'm Seunghak Lee from KSCE. I'm a principal research scientist in Korea Institute of Science.
Once you get your presentation up. And I think we have enough time that we can take questions after each presentation, and then we can do a general discussion after that. And I know a lot of you here in the audience have water experience, so I'd love to hear your comments and join in the discussion. So thanks so much. So just be a moment.
It's okay. I think it's.
Yeah, so we just want one.
Yeah, sure. Okay, good afternoon, ladies and gentlemen. I'm Seunghak Lee from KSCE. I'm a principal research scientist in Korea Institute of Science and Technology, and I'm also serving as a chair of international affairs in KSCE and like a planning committee chair in ASECC. So in the previous presentation, Dr. Lei has mentioned about the like extreme rainfall, which is going to be severe in the coming future by the climate change, absolutely. And this is kind of a connected and like inspired study regarding the extreme rainfall. So, which means the extreme rainfall can making a problem related to the water disaster, as well as the water quality related problems. So I hope this presentation might give you a like a message that how our science and technology can clarify or identify the uncertainties in the coming futures related to the water. So I'm gonna share one of the research findings recently found in our recent research, and is related to the groundwater, and especially the groundwater quality. So let me start from this image that might be shown in the lots of previous presentations, especially related to the climate change. So this figure shows how we can suffer from the shortage of the three different resources that we are using every day. So climate change can cause the shortage of water, food, and energy. But if we try to increase the amount of one resource, then we have to pay the other two. So this figure is typically called as the perfect storm scenario, but I don't want to go deeper regarding this one, but I want to just focus on the shortage of water. And related to that, want to give a focus on the groundwater as a available water resource in the future. So in 3 or 4 different water types have been estimated with the 3 different perspectives. So groundwater has a higher storage and residence time as that type compared to the surface water, which give us the implication of its an availability in the shortage of the surface water, which we are more reliant on so far. But this groundwater is could not be perfectly safe because it is exposed to the different kinds of contaminants, which can degrade its quality. So one of the important contaminants we have to give a concern is the nitrate. Nitrate is the most an oxidized form of the nitrogen, and which can come from these different sources. And among those, the nitrogen-containing fertilizers here is the major source for the nitrate. As you can see, the usage of nitrogen-containing fertilizer is still increasing globally, which means gives us the higher chance of contamination for the groundwater, which underlying, which located in the subsurface. So I want to give you an apology in advance for since I didn't have much time, so I spent such a hectic time to prepare this presentation. So it might not be strongly logical or a little bit awkward, but yeah, please, I beg your understanding on that. So, okay. I'm not going to the deeper, but I should mention the importance of nitrogen as a separate element. Okay. So do I have 5 minutes left? Okay. So, but April, can I use a couple of more minutes? We might have no a presenter at the third order, right? Okay. So, okay. So this is the figures how our Earth, planet, is suffering from the different causes of the environment, or from the social and natures and everything. So as you can see, the nitrogen itself is beyond the capacity of the Earth already. So it is more severe than the climate change itself. So we need to get a solution to effectively manage the nitrogen which is spread along the nature. The nitrogen can transform into the different form, especially in the subsurface. And as I've said, the nitrogen contaminants exposed to this ground surface can be transformed into the nitrate while traveling through this layer and finally touch down to the groundwater. But staying in this region, it can be transformed into the different kinds of nitrogen forms. So we call this as a oxidation or reduction process or biogeochemical process happening in the unsaturated zone. So subsurface can be divided into two different regions. Above the groundwater level, the pore is not the subsurface pore, which is formed by the contacting of the soil particles, is not fully saturated. So we call this region as unsaturated zone or Vadose zone. Contrast to that, this zone, all of the pores are saturated with water. So this is called as saturated zone or aquifer, through which the groundwater is flowing. The one thing is that the nitrogen can be naturally treated or remediated through the biogeochemical reactions called as denitrification, which involves microbial activity inside. But that denitrification is directly affected by the surrounding condition. What you have found is that it's quite closely related to the water contents in the Vadose zone. Because if the nitrate introduced in the subsurface is properly treated or properly denitrified while traveling through this Vadose zone, then it's gonna be untoxic, non-toxic when it's getting into the groundwater because it can be converted to the nitrogen gases. Okay, so we have estimated their potential risk by performing this kind of like a well-systemized laboratory scale experiments. And we have found that contrary to the previous findings, even under the unsaturated condition, so that some pores are open to the atmospheric condition, the denitrification can happen. But as I've said, that denitrification process is affected by the pore saturation condition, right? So how many minutes do I have? 3, 5? Okay. So, but the water contents in the subsurface can be directly affected by the precipitation, more precisely precipitation pattern, right? But now we can expect that precipitation gonna be like this. The intensity and the frequency of the extreme rainfall are increasing. That's what you have observed. You can check that in the previous scientific research here. So we try to estimate how those heavy rainfall can change the Vadose zone denitrification potential to the nitrate. Okay, so we have constructed this system by connecting different kinds of sensors. We can identify the status of the geochemical conditions inside there, and also which can simulate the different like a precipitation pattern on the top. And this is the scenario we have employed for running this experiments. So the precipitation pattern, which can simulate the past precipitation pattern, so not so heavy, okay? And then it can be how can I say, it's stable, right? but the same amount of water can be poured down in a short period of time. This is like a future precipitation pattern, and we simulate this like a precipitation scenario onto that columns and estimated what's going on inside that Vadose simulating column system. So I'm gonna skip this data and want to show this one. We have found is that the SL represent the silty loam, which has one of the soil textures we can find out in the subsurface. And SLS represent the loamy sands. This is another kinds of soil texture we can encounter in the subsurface. So there is some differences in the degree, but in general, we have found that denitrification efficiency in the Vadose can decrease under the future precipitation pattern. This might be due to the different like a water flow into or infiltration patterns which can be formed in the different precipitation scenario. And we also have estimated the microbes diversity in the Vadose to confirm the mechanisms we have supposed to be happening there. And this is the kind of take-home message. So we are now preparing a publication related to this research. And the main message is this: denitrification, which can reduce the nitrate toxicity before getting into the groundwater, can be reduced under the future rainfall pattern. So thus, the groundwater vulnerability to the nitrate can increase in the future under this climate change, which is going to be expected to maintained. So how we can use those findings in our like a planning, policy, and engineering countermeasure. So we can build up some like a quantitative expectation for the natural attenuation capacity of a certain Vadose using their different like parameters. So this equation is the one thing we have developed to out of our research. Then we have built up respect to, to a specific region which was used as our test bed. And we can plot their potential like a natural attenuation capacity for the nitrate. And we can build up this one just using the soil properties underneath. But if we can like combine the precipitation scenario, then we can make an advancement for the prediction in those areas, how the nitrate contaminants can be naturally degraded or naturally purified. So as you can see, the four figures seems to be similar, but a little difference can be found in the summer season, which means the high, like a heavy rainfall is like a comment going into those areas, the denitrification efficiency of the Vadose can be changed, more specifically, more precisely can be reduced. So the groundwater underneath those regions can be exposed to the contamination. Okay, was so quick. Thank you. Okay, I have spent longer time than I supposed to have to spend, but if you have any questions, I can give you a quick one. Yeah, please.
Yeah, I know you said the
the denitrification is reduced under the heavy precipitation scenario because of the climate change. But at the same time, there is dilution of the concentration of nitrates. So how does that play overall? Because you're really worrying about the concentration of nitrates in the groundwater ultimately, which discharges somewhere, either to surface water in a river or in a sea. So how do those play against each other? The denitrification is reduced, which is not good, but then it's diluted, the concentration is diluted, which is a little better. So how do they play out against each other? Yeah, it could be that too.
Okay, that's very good questions. Actually, I got the similar questions in my previous presentations and writings. And so my response was this, but I'm still considering that because we have excluded the analysis from the hydrology itself, right? We just focus on the biogeochemical reactions happening in the Vadose zone. So these results are based on only on that reaction, right? Denitrification, or we call that as attenuation capacity. We only focus on that in this analysis. But for estimating or predicting that the overall, like a groundwater vulnerability to the nitrate should include the analysis on the hydrology. So, okay, I agree with that. Yeah. Yes?
Thank you. Nice presentation. Just a small question. You have discussed the Verizon during the precipitation, but what about the drought conditions? What will happen under the drought conditions in the Verizon zone about the nitrate and the nitrogen?
Okay, that's another good question. I have skipped this part, but actually this precipitation scenario has been applied times, which means, so on the first day, we give the precipitation and the whole week has allowed for the drying, right? So, but you are asking about those zones are, if those zones exposed to the, like a continuous drying condition, what's going to be happening, right? So all of those pores, if those pores are dried and unsaturated, then the nitrate can get an express to the groundwater. So it can
Stack up in the Verizon.
stack what?
Stack up in the Verizon. That's what you said. That won't reach the groundwater.
Yeah, the one of the like in behavior proper.
Stack up in the Verizon. When the precipitation comes, it is already a concentrated columns of nitrogen within the Verizon. Then the effect will be much adverse. Drought condition turns into precipitation, and then if it is not going down, then I just want to know whether that has been studied in your model or not. That's all.
Okay. Yeah. Okay. Let me just clarify your questions. Okay. So nitrate itself has a negative charge, so it cannot be bound on the soil like a layers. So if it like in dissolving the water, so it can like it directly go down to the like a groundwater. Yeah. Is that what you're asking?
No, but it is not going to happen. One of the major sources is pesticides and fertilizer.
Mm-hmm.
Fertilizer
Should go inside.
goes as a runoff, and runoff goes into the soil. So, and it flows under the flow nets, and then if it's a drought condition, it will stack up within the Verizon.
Possibly, yeah.
And
Possibly.
when the precipitation comes,
Then it can go down
it
again.
will go
Yeah.
down, and that will create more
It's, yeah, that's possible. That's also possible. Okay. Yeah. Is that all? Okay, yeah. Thank you.
Thank you, Dr. Lee. That's fantastic to hear about what's happening with the groundwater system, since we've been talking a lot about generally groundwater and all the climate cycle. So thank you. So our next speaker is Professor Tung. So thank you very much for coming up. You're here from Taiwan, so we'd like to hear a few words of your introduction once, if you don't mind. Thank you.
你打开看吧，这太小看不到。可以点啊，应该是另外那个，不是。你弄掉。Okay, first, thank you to be here for my talk. Before my talk, I will introduce myself. My name is Ching-pin Tung. I'm a professor in the Department of Bioenvironmental System Engineering, and used to be the agricultural engineering. So I changed a fancy name for attract more students. And I'm in National Taiwan University. My topics were related to climate change risk assessment and how adaptation for water resources. In fact, I will beyond water resources. I will talk more general adaptation framework and answer some questions from the Korea EAS. If we have a heavy rainfall, how can we do for the end of this century? In my opinion, we don't worry too much. We won't be there for the end of a century. But we do have some philosophy, some framework to deal with these problems. I will introduce this. So I will give you some background information related to Taiwan situations caused by the climate change. And then I will provide, we call the climate adaptation algorithms, including the standard procedures and a template to decompose the climate risk, and also the climate adaptation pathway, which is the answer to the guys from Korea. It's about dynamic adaptations. We cannot do the adaptation at once. We need to keep frequent adjust our adaptation strategies, but we need informations. So these are tools to try to develop dynamic adaptations. And also, I think the climate adaptation service is very important, not only for the governmental agency, but also for the industries, even the community-based. So we try to develop a climate adaptation service. Not only the service, but also the knowledge is established. So we also have a Climate Adaptation Teaching Alliance. So I will briefly to introduce this alliance also. So we all know the ESG is become more and more important in these days. Not only the impacts, but also we call the net zero emissions. So the ESG is very important, but ESG is not the environmental protections, do some benefit for the societies, but in fact try to reduce the risk and increase opportunities. So ESG should be environmental governance and social governance. When we try to understand the environmental risk, we try to reduce these risks to increase opportunities. We need to provide information, especially for industry and the local government, even the communities. They don't have ability to evaluate, to assess the risk of floodings. They need some assistance. They need information. So how can this information provide based on science research? It's very important. So we can see the environmental aspect, including the climate change strategies, biodiversity, water resources efficiency, and the environmental management systems. All of these are very important to the industry nowadays. If you notice that in Taiwan, all companies need to publish their financial report based on international financial reporting standards. And the IFRS just issued 2 standards to the sustainability disclosure and the climate disclosure in the June 26, which means all companies publish the financial report at the same time. They need to publish the climate-related financial disclosures. They need information. This is legal requirements. It's very important. This is not just the research, science research. We do science research, sometimes say, oh, I'm sorry, I'm wrong, so I redo again. Industry is not this kind of issues. You have a responsibility to your shareholders. You cannot be wrong. So how can we provide this information to them? Make sure this company or industry don't make errors, don't make mistakes to their report. It's very important. It's very serious. This is not only the science research. This is the real world. So we call a lot of climate actions. Right now, it's real actions. Real world need. So we do a lot of climate science research. In fact, I have my master and PhD degree from Cornell back to the 1990. My master degree, my thesis topic is climate change impact on New York stream flows. So I evaluate the climate change impact on stream flow back to the 1990. Then, okay, that's a serious impact. Then what? That's not my business. I just tell you that, yes, that's impacts. But industry cannot adopt this information for their business operations. No, they cannot. So we need to provide more valuable, more precisely information for them. So how can we, based on our climate change science, to enable climate actions? It's very important. We need to provide the correct concept, knowledge, and tell this industry the logic. Those industry even don't know any related to climate change, but they need to know the logic. For example, what the climate information means. That's different from the disasters. This climate change for long-term informations. There are a lot of uncertainties. And then enable the take actions. So this is some information the director of water resources just mentions. We have more and more rainfall, higher and higher rainfall intensity. For example, the Taipei area. You can see in the 2015, the June 4th, there's a maximum hourly rainfall is 131 millimeters. And the director just mentioned the drainage capacity of the Taipei city is 78.85 millimeter per hour. So which means much higher than this one. And the year 2019, the nearby the Dan Forest Park measures 36.5. And the year 2021, the measure is 209. The rate number is not because the number is so high. It's because someone said the device is malfunctions. I'm sorry. This number is maybe not right. But you can see the rainfall become higher and higher. But in fact, you can notice there's a rainfall event 201 millimeter per hour in the mainland China, Zhengzhou, in the year 2021. So this is possible. So if our drain system has a capacity of 78.895, and then we have this higher and higher rainfall intensity, how can we do? It's impossible to expand the drain system all the way or once. We need to have measures to adapt to these changes. But it's impossible to enlarge our drain system in maybe every 5 years, every 10 years. It's impossible. So we need to have different thinkings. We need to have some management systems. And not only the heavy rainfall, but also the drought. The director just mentioned in the past 5 years, he said, unfortunately, I'm happy about that because typhoon also caused a lot of damage in Taiwan. But in fact, the inflow of the reservoir really induced by the typhoon. So you can see the year 2018, in the spring, we have a wet season from May through November. That's wet season of Taiwan, which means by the end of wet season, the reservoir should be full. But you see here, the year 2020, the winter, that's in southern, the Zhengwen reservoir is the Taiwan largest reservoir. In the winter, it should be full, but it's empty. You see the grassland is not beautiful grassland, it's bottom of a reservoir. So you can see the year 2018 and the 2020, these 2 years, we all have the very serious drought condition in Taiwan. So not only flooding, but also droughts challenge Taiwan. We have these 2 challenges at the same time, and more and more frequent. So the TCFD, the guideline, the Task Force on Climate-Related Financial Disclosure, proposed 2 kinds of climate risk. One is the physical risk. This physical risk result from the drought, flooding, landslide, storm surge, and heat wave, maybe cold conditions. We exposure to this hazard, then result in risk. This we call it physical risk. And we want to reduce the physical risk. We need the resilient adaptations. On the other hand, we want to reduce the greenhouse gases impacts on climate. We need to mitigate the increase of greenhouse gases emissions. So some supply chain try to request their supplier to reduce emissions. Government start to collect tax fee or carbon fee or carbon tax. Some countries try to have a border tax. For example, the Europeans, the state bank try to collect these monies. I try to ignore you. I have only 5 minutes. Okay. So not only governmental agency, but also the industry need a systematic method and the knowledge service. Try to enable them to have better adaptations. So I will briefly introduce the climate adaptation algorithms. This algorithm, we have a published paper maybe 2 or 3 years ago, and consists of 3 components. The first one is the standard procedures. The first procedure tries to identify problem and goal, and then assess the current climate risk. In fact, assessing climate risk more related to the disaster reductions. Because in Taiwan, I don't know whether or not your country had the same situation. People sometimes don't know what's the difference between the climate change and the disaster reductions. So we try to make them difference, but I think it's difficult. So cannot make that difference, then we include the climate disaster reductions. So the step 2 is try to do the disaster reductions. So based on this situation, then we further evaluate what kind of climate scenario, what kind of climate scenario will result in what kind of a risk. Then we try to develop the adaptation options. These options may be enlarge the current strategies, may be developed in the new strategies or new actions. And then we also have a planning adaptation pathways. And then we also design the monitoring and revising systems. So that's why I call it dynamic adaptations. In order to make these dynamic adaptations more efficiently, we also adopt we call the climate adaptation pathway. In fact, this methodology is proposed by Nissan. So in this component, we have procedures and template and this adaptation pathway. And this template is called, according to the experience in Taiwan, for some, even the environmental governances of officers, this is difficult to decompose the risk. So we based on the IPCC definitions, the risk is function of hazard, exposure, and vulnerabilities. And then we further to decompose what the factor impact the hazard and some non-climate factors, and what's the factor impacts on the exposures, or some factor impact on vulnerabilities. And also we try to ask them to identify what's the institute you present, in what kind of viewpoint, and what's your protect object. For example, here is a case for the Zhonghua Telecoms. They try to evaluate the risk on their telecommunication cabinet. So the issue here is the telecom cabinet's exposure to storm inundations result in malfunctions. So the hazard here is inundations. So exposure is a spatial distribution of these cabinets. And vulnerability, of course, may be related to waterproof abilities, or maybe the potential height. The height here, the yellow buttons try to, if they allow some kind of inundations. So accordingly, we can, of course, for the inundations, for this telecom company, they will not they can do, but don't think they have to. So this should be done by the Water Resource Agency. So they provide this hazard map due to different climate change scenarios and provide this information to industries. So they can adopt this information for their assess. That's for industries. And this is another example is done by the National Center of Disaster Reductions by the Dr. Wu. He tried to produce the hazard map of landslide. This, in fact, is in charge. It should be the responsibility of Ministry of Agriculture. And this information can apply to the Water Resource Agency, for example, the reservoir exposures, or maybe to the Ministry of Transportation, the road systems, or maybe to the power transmission tower. So this is kind of exposure information. And then adopt their vulnerability. Vulnerability means this device, this protect object, whether or not sensitive to this hazard. So according to this, we can produce the risk map. So this, we call it a multi-governmental agency partnership. So this is also very important for futures. And as we say, it's impossible we prepare the measures, adaptation measures or past strategies for the end of these centuries. We need climate smart adaptations, which means we need to take the most proper action at the best times. We need to do it at the best time. So we need to know when should we put this action in act, when we should implement these actions, when should we change different actions, when should we need new actions. Maybe we may stop some actions. So we need this kind of info, this kind of tools. So this is not proposed by me, it's proposed by a professor from New Zealand. They call it the adaptation pathway. We have different actions. You can choose action A along the times. Maybe you can choose the action B, and sometimes you switch to action C according to the threshold or tipping point. So based on this kind of mechanism, you need to evaluate the tipping point. When should you change your actions? Or when should you add new actions? Maybe sometimes you need to stop actions. So I call it dynamic adaptations. Okay, this is an example corresponding to the telecom cabins. And the last two parts is called, also very important service. We have a lot of research. Governmental agency or research academic society produce a lot of science information and knowledges. But for the industry or some local government, they don't know how or where to get this information, or how can they use this information. So we need a service, we need a server, try to deliver the data, information, knowledge. The DIKW means data, information, knowledge, or wisdom, and also tools as a toolbox to the clients. And clients may be the general public, maybe industries, maybe governmental agencies, different governmental agencies, or local governmental agencies, and also some general public. So how can we develop this? So we try to have a one hub stations. So all information will collect by this one hub website. But of course, we will not collect all the data. Some data will store in the different database. So here will be the meta database to teach them how can you access these data. So this data and again, different users can via the API to acquire this information to develop their own decision support tools. That's the idea in Taiwan. And the last part is education and training. So we develop a climate adaptation teaching alliance. This alliance tries to establish some teaching materials for the universities, because in the past 20 years, a lot of courses without any climate change information. We need this information into the university courses. So we try to develop this alliance and to invite the professor from different universities from Taiwan. Of course, we also welcome from all other countries. And we try to provide the teaching materials, practice materials, and we provide some training workshop to train instructors and train university teachers. We also train the students because when a professor wants to open a new course related to climate change, new course, which means he don't have any graduate student know these issues. So that's difficult for him to have TAs. So we train the TA also. So we try prepare materials, try to train the professors, try to train their students to empower these courses. This is our core content and our goal. So final remark, I think the accurate and the transparency science information is very important. And this information should be accessible and easy accessible. And efficient use of a water resource, I'm sorry, I only mentioned water resources here. It's also very important. How can we use it very efficiently? Not use as little as much possible. In my opinion, sustainability means we can use our resources very efficiently. So that's how can we do that? So we need to help our industries, not just give them rules, the requirements. We need to teach them how to do that. And also, I think the transdisciplinary research and multi-level governance also very important. Some local government don't have the ability to evaluate the risks. They need the central governmental agency to provide these information. Based on these information, they evaluate their exposures and their vulnerabilities and more focus on reduce exposure and reduce vulnerabilities. Okay. And also the public-private partnership also very important. As I mentioned, nowadays, the company require these informations, which means, for example, the financial institute, they are in Taiwan, they are more willing to have money to help to establish these data, not only for the society, but also for their own business. So I think there's a very good chance we have this public-private partnership. We can also have some private fundings to help the society to establish. And One Hub Climate Adaptation Service is also very important. And the Teaching Alliance try to establish knowledge, not only for the university, but also for the industry, even for the general publics. And also, a lot of study mention how can we evaluate impact on sustainable development goals is also very important. Okay, that's my talk. Thank you.
Thank you, Professor Tung. Did you want to answer a couple questions? We'll just do it very quickly because our next speaker is on a schedule as well. But do we have any questions? Yep.
24.
At the universities, so
Yes.
I'm interested in the
previous one? Or previous one?
Yeah, previous one, very previous.
Yes.
Yes, I'm interested in the Teaching Alliance. Could you tell me once again about the trained instructor? Who is the trained instructors? Who trained them?
Okay. We have some more experienced professors. And then we try to train some new graduate PhDs or the postdoctor of the professors. And some professor in other university, they want to open some course related to climate change. They need prepare. So the first year, we have some manpower to support him. For example, have a course provided by the trained instructors. So which one can unload some loading of the professor want to open this course? Yes. Or maybe 10 years ago. Yeah. Ongoing. Ongoing. Yeah. I think we are very willing to maybe we can expand this alliance to international alliance. And we also can also exchange these teaching materials because some of the teaching materials will have very similar contents. Of course, local have local conditions, but the general frameworks are very similar. So I think it's a very good idea to share with each other. So if your country have this interest, maybe contact with me. Yeah.
Thank you.
I'm sorry, I need to run for my course. My course is wait for me. I'm sorry, I need to leave. Thank you.
Thank you. So our next speaker is online. So it's Dr. Costa, and he is in New Zealand. So we'll just get his presentation up for him and make sure we're all set up technically for his presentation. And then after that, we'll have a question and answer session with speakers that are here. So, or we can just among ourselves as well. So just be a moment.
Yeah. Can you see the presentation? Can you see the slides?
We can see it. You might want to put it on slideshow mode though, and we can hear you.
Right.
Go ahead and
Fantastic.
start when you're
Okay,
ready.
I'll just let it be like that. Yeah. Okay. So I'm Gregory from New Zealand, and I'll be talking about water management due to climate change impacts. So, well, everybody, the previous presenters were all talking about this. So these are about a case study in Wellington. So which is here. I suppose all of you are very familiar with it. So it's the south of the North Island, Wellington. So moving on, these are satellite image, and as the next slide, I'll first get this slide on. You can see that these both sides are mountains, and here in between is a valley, and we call this valley the Hutt Valley. So in the middle runs the Hutt River, and below this is the Hutt groundwater zone. So we have the surface water running on top here, the Hutt
Sorry,
River.
Dr. Costa, are you able to put this on slide mode? Do you know how to do that? Just to make it a little bit bigger for our audience. There we go. Thank you.
Is that okay? Yeah,
Yeah,
fantastic.
that's fantastic. Thank you.
Okay, right. So do they see the cursor though? Can you see the cursor moving? Yes or no? I can't hear you.
Yes, you can. Thank you.
Fantastic. Okay, brilliant. So this is the Wellington Harbor, the water, and this is the Hutt River, and this water flows in there. So as I told you earlier, this was how to go one by one, is it? Slides are not moving, isn't it? All right, okay. You can see, no, I presume, yeah. Okay, so this is that, and I'll just move it on for time's sake. So this is the seawater level from 1900, data from 1900, so it's over 100 years, and the water level seawater level has been by 20 centimeters. That's coming around 2000. So here we are in 2000. This 2023, this research was done a few years back. So at this point also, it's a continuous water level rise in up to 2020. So basically, we've seen a 20 millimeter water level rise, and of course, you mathematically model it. We can see the four scenarios: the green, the black line, the purple line, and the orange line. So this is just the sea level rise. Now, on top of that, above the sea level rise, we also have on some days there could be storm surges, which is the temporary increase in sea level above that expected by tidal variations. And also we have the wave setup, which comes into play. So there are three aspects here, and all these three aspects can come into play. So with that, the water run into the coast can vary. So we model this, and I'm getting a bit, why isn't this now coming on? Right. So we have modeled this, and for sea level rises of 1 meter from 0.5 meters to 1 to 1.5 meter, we could see on some days there could be a total height variation from 2.7 meters to 3.7 meters. But this 2.7 meters to 3.7 meters is a temporary thing. If it'll come into play only if there is storm water as well as uh, the the conditions change. Otherwise, it can be only up to 0.5 to 1.5 meters. Now, if the sea level rises by 0.5 meters, considering all these things, for 0.5 meters, we we have modeled it and found that this yellow area is how much the water will come in. And as it starts increasing to 1, further the yellow area further increases to 1.5, it goes on like that. And as it becomes 2, this whole place goes underwater. So basically, it is clear that if the sea level rises by 0.5 to 2 meters, this is what we can expect in New Zealand. So I'll repeat it. This area is called Petone, and people reside here. So how we manage this, we'll come to that later. Right. So basically, the estimated loss of land from 0.5 to 2 meters is about 0.84 square kilometers to about 1.7. Basically, it can be about 3% of the groundwater zone to about 6.5% of the groundwater zone. So the strategy that we came up was, I mean, you can't construct dams and levees and escape from this, because sometimes you get 2-3 meter high waves coming up. As one strategy, the passive strategy, to alienate the land from the coast. Ideally to have a 500-meter belt for parks and low-cost infrastructure. In case on days the water runs off, the damage to life will be a minimal. Moving on, that's one aspect of the way sea level rise and the water impact of that. Another impact is in Wellington, we have the aquifer, as I told you earlier. Below, this is the Hutt River. This is a schematic diagram. So this is the Hutt River, and below that is the aquifer. So 43% of our water comes from the aquifer. This aquifer is called the Waiwetu aquifer. 43% water comes from this aquifer. Water is pumped out from the aquifer. Now, another schematic diagram, if you assume that this is the sea level and this is the land, then we have the groundwater. The groundwater table is about up, let's say somewhere here. And from pumps, we are pumping from here. But below the land is the seawater, again, the seawater, sea level, and the groundwater is on this side. And there is this mixing zone, the diffusion zone between sea and water. So the moment we start pumping out groundwater, the cone of depression comes into play, the hydraulic pressure starts varying, and the diffusivity undoubtedly will change, and we see seawater including the groundwater system, which we call the well-known salinity intrusion. So salinity intrusion is also another problem with sea level rise. And of course, sea level rise is because of temperature rise, climate change. So again, we have modeled this, and we have found that even the sea level rises slightly if we don't pump from the well, from our pumping stations. We don't see any salinity intrusion or seawater coming in. But the moment we start pumping at 15,000 cubic meters a day, we can see the salinity marching in forward into the aquifer. Again, we have modeled this with various scenarios, done with various scenarios. What we found was an important aspect is recharge. If we recharge the aquifer, then we are safe. So here I just put 2 diagrams. Or if you're recharging at 400 millimeters per year, then even at 15,000 cubic meters per day, we don't see the salinity level moving forward. And at 25,000 cubic meters per day, also we don't see it. We marginally see it. So what it tells us is that recharge is an important aspect here. And if we recharge, we can escape. Okay, so we have the natural recharge, of course, because of rainwater. So in that lower groundwater area, a month by month variation of rainwater is something like this, and the annual mean is about annual minimum mean is 476, while the mean is about 800 millimeters of rainwater we get in that zone. Of course, varying. So it varies from 400 to 1,300. The 1,000 millimeter variation is the mean there. And we need to, if we can collect this and recharge this, we are basically sorted. We don't see salinity intrusion occurring there. So how do we recharge is another aspect. So of course, there are methods to do that. We all know that infiltration wells and dams across the rivers and so on and so forth also helps to recharge. Again, we analyzed 4 scenarios for sea level rise from 0.5 meters to 2 meters. If the water level rises, what will happen to the groundwater table? So you will not be familiar with these things, but the hut recreation ground is closest to the ocean, while the last one, Taita Intermediate, is the furthest from the ocean. So these are the midways are places as you go along from the ocean. So basically, if you the groundwater table, if the sea level rise is 0.5 meters, we are expecting a change in water table of 0.17 at Somes Island. And as you go down, as you go further inland, it decreases. So the seawater level rises by 1 meter. Again, we are expecting 0.6 meters of water table change. And and as you go to hut recreation ground, 0.45 and so on. So as you could see at scenario 4, even at 2 meters, then of course we see a significant water table change even at the Taita Intermediate of 1 meter. So basically the water has risen. So what does this mean is it gives rise to flooding. These of course is a photograph of a different location, but a recent rainfall and immediate flooding. So in conclusion, I'm going to skip these slides. In conclusion, while on the one hand we can try to reduce climate change variables such as temperature, spatial distribution of rainfall, temperature, and sea level rise, on the other hand, we can develop mitigatory strategies to minimize the impact of, because the impact is the important thing here, impact of changes to these variables. So like I said before, we can alienate land instead of going and constructing. Then the pumping wells about the ground, as pumping wells of the water can be moved up, or we can recharge the aquifer so that seawater does not impact. We can try develop various methods to recharge the aquifers. The level of groundwater increasing causes 2 things. One is it causes easy flooding. That's a problem there. But as you could see, as you go upstream, the impact decreases. So while climate change is an issue, we need to adapt with it. So while we can try to suppress it on one side, on the other side, we have to also adapt with it, and we can develop various adaptation strategies as mentioned before. Thank you.
Thank you, Dr. De Costa. Do we have any questions for Dr. De Costa? Any question? Do we have any questions that are online? Can we just double check? No? None online? Okay. No? Okay. So we can just open up the floor for discussion with Dr. Lee and Dr. De Costa, and all of you who are here certainly welcome to hear any comments or questions that we might have. Any comments, questions? No? If that's the case, then we will finish for the day. Thank you so much.
Thank you. Thank you.
Thank you, Dr. De Costa.
Thank you.
And
Thank
I
you.
would like to
Thank you.
mention that we will have a TC-26 meeting in New Zealand probably next September. So we'll be looking forward to
brilliant.
hopefully seeing you again. Well, it won't be TC-26, it'll be an ASECC meeting. That will be the 45th
Brilliant.
ECM.
Brilliant.
Most likely in Wellington. So yes.
Fantastic.
And we do have a question.
So my question is very broad. Excuse me. Can anyone speak to how green stormwater infrastructure could be an adaptive approach to managing water sustainability under changing climate and even nature and natural-based solutions?
Would you like to try to answer that one, Dr. De Costa?
Yes, of course. So the question was, sorry, could you repeat that? Green storm?
Green stormwater infrastructure. Green stormwater infrastructure.
Yeah. Well, here, I mean, in New Zealand, we are already adapting some measures like that in Auckland, particularly, which is one simple thing is that as they subdivide the catchments, they need to store their own water, the catchment runoff, the runoff from their houses. They need to store it. So if I so basically tanks, very novel tanks which can be used as fences, as fencing, or as walls are being developed up and placed. And what is discharged from the houses are all first stored inside that and then slowly released. So this will, if majority of the people have this, basically we have a storage, initial storage before the water gets discharged into the system. And therefore at heavy rains, of course the tank must be empty before that. At heavy rains we could collect and discharge, reducing the impact on the main national storage systems.
Thank you. There we go. So I want to thank our speakers and our participants today, and as well as our hosts who have been here, and our technical people have really made a big difference for us. Thank you so much, and we will see you hopefully at our next ASECC meeting in Manila, which will be next late February. And also, like I mentioned, in New Zealand, we have another meeting, and then CCAR 10, which will be in October 21st to 24th in Jeju Island, Korea. And TC-26 will have another session or two there, so hope to see you there. Thank you so much.